In this next lesson, we're going to answer the question, how do you rewrite expressions using the properties of multiplication? In the last lesson, we looked at the properties of addition, the commutative and associative properties of addition. This time, we're going to get into the commutative and associative properties of multiplication. Take a look at workbook page 192. You can see in example 1 a situation where we have a rectangle and we're trying to find the area of that rectangle. And you know to find the formula, the formula for the area of a rectangle is base times height, or length times width, whichever way you want to look at it. Look at it in this situation. Here we have the first rectangle where it looks like our length is A and our maybe we could say our base is A and our height is B. Well, you would have to do A times B, base times height. Or maybe you want to do length times width here. Your length is B, your width is A, or again, base times height, B times A. No matter which way you look at it, those expressions are equivalent. A times B is going to give you the same thing as B times A. The area for that rectangle isn't changing no matter how you do the multiplication. That is the commutative property of multiplication. Basically, the order doesn't matter for multiplication. In example 2, you're going to see that there are A trucks. This is our situation. There are A trucks, meaning I have no idea how many trucks. There's just A of them. There are B boxes in each truck. Take a look at the diagram here. They're using these big green rectangles to represent the trucks. And then they're using the yellow rectangles inside to represent the boxes that are in each truck. Again, I don't know how many boxes are in each truck. I just know that there's boxes in them. Then there are C soccer balls in each box. So inside each of those yellow boxes are those little green dots. And they're representing the soccer balls that are in each box. But again, I have no idea. I don't know how many soccer balls are in each box. I don't know how many boxes there are. And I don't know how many trucks there are. So how can I write an expression for this? Well, maybe I want to take the trucks, which is A, the number of trucks, and multiply it by the number of boxes, and that'll tell me how many boxes are in each truck. But then if I want to know how many soccer balls that is, I would have to do that product times C. So the number of boxes times the number of balls in each box. Or maybe I'll work backwards. Maybe I'll figure out how many balls are in each box by doing the number of boxes times the number of, the number of soccer balls, not in each box, but total. I would have to do the number of boxes times the number of soccer balls, and then eventually times that by the number of trucks. So here you can see some equivalent expressions. This is showing you the associative property of multiplication. Basically, the grouping doesn't matter. No matter what, it's all multiplication. You can do that multiplication any way you want, group them however way you want. Okay. Workbook page 193. This should look familiar to you because we're going to be talking about coefficients in this lesson. If you remember, a coefficient is basically a number that's multiplying a variable, or maybe it's multiplying a product of variables, several variables multiplying together. Take a look at the examples below. So here in 3a, the 3 is the coefficient because it's multiplying the variable a. Here, in this term, 7x to the second power, 7 is the coefficient because it's multiplying x to the second power. In this term, 8 is the coefficient because it's multiplying the product of x and y. Or, look at this one, s to the third power. Guess what? There is a coefficient there. It's a hidden coefficient of 1. So here you can say that 1 is the coefficient of s to the third power. Now, you'll notice in all of these, the coefficient always came first. It was always the number in front of the variable or variables. In algebra, we usually write the coefficient in the front of a term. If a term is not in this form, you can use the commutative and associative properties of multiplication to rewrite it. So if you look at 193 at the examples, you can see we have a term here of 4x in parentheses times 5, which is outside the parentheses. Well, I'm going to rewrite it. So we're going to rewrite this so that our coefficient is now in front of the variable. We don't want all of this multiplication just jumbled together. Take a look at the steps here. All that we've done is we've taken that 4 times x in parentheses times 5, and we have just kind of spread it out so that you can see the multiplication signs in there. 4 times x is still in the parentheses, multiplying by 5, that's still outside the parentheses, but you see the little multiplication dots. Next, we can use the commutative and associative properties to rearrange and regroup these. So maybe the first thing you might want to do is regroup it so that the parentheses aren't around the 4 and the x, maybe they're around the x and the 5. And then, oh, remember, commutative property says that you can change the order. Maybe instead of doing 5 times x, I can do, maybe instead of doing x times 5, I can do 5 times x. So that's what's happening here. We just rearranged the order of the factors in the parentheses. And then we can regroup again, but the parentheses are now around 4 and 5, because we can do 4 times 5. 4 times 5 gives you 20, and you're still multiplying with x, so it becomes 20x. Your coefficient is actually 20. Take a look at example 2. Same thing. First, rewrite it so that everything is just a little more spread out and you have your multiplication signs in there. So 6 times x is still in parentheses, 3 times x is still in parentheses, and they're multiplying them. So there's 3 multiplication signs now. And let's see, the associative property says, I can rearrange, I can regroup. Maybe instead of having parentheses, around 6 and x and 3 and x, maybe I'll have the parentheses around the x and the 3 in the center. And then after I have them in the parentheses, I can rearrange them so the 3 comes before the x, so it's 3 times x. And then regroup again, so now it's 6 times 3 in parentheses, x times x in parentheses, and then you can actually do this multiplication. 6 times 3 gives you 18. X times x, well, that's x to the second power. Your coefficient becomes 18. 18x to the second power is the full term. Let's do a few more together. Take a look at number 9. Let's see, we have 2 times y in parentheses times 8. I'm going to change it around, so I'm going to maybe get the 2 times the 8 to be in the parentheses, and then the y to be on the outside. So I can use the commutative property to rearrange and the associative property to regroup. And now I can actually get 16, 2 times 8 is 16, 16 times y. 16y is the new term, and the coefficient is 16. How about number 11? Number 11, let's see, we've got 1/2 times, and then in parentheses we have 3/4 times b. So I'm going to rewrite it so that maybe I'll get the 1/2 times the 3/4 to be together, and then b would be on the outside. And 1/2 times 3/4 gives you 3/8, and 3/8 times b is 3/8 b. The coefficient here is 3/8. And the last one, let's see, 2 times a in parentheses times 3 times b. I'm going to rewrite it and regroup. I want that 2 and that 3 to be together, and I want the a and the b to be together. So I want the numbers together and the variables together. 2 times 3 gives you 6. A times b, well, that's just a times b, because I don't know what a or b is. So now I have 6ab, and the coefficient here is 6. Now, on workbook page 194, we're going to put it all together. In the last lesson, we're using the commutative and associative properties of addition to combine like terms, and in this lesson, we're doing the associative and commutative properties of multiplication to rewrite it so the coefficient is in the front. Let's do it all together. If you remember from PEMDAS, we always did multiplication before we did any addition, right? Let's keep that in mind. The first thing that you have to do is you have to rewrite the terms with the coefficient in front. So instead of having 2 times 3 x in parentheses, I'm going to turn that into 6x because I can rewrite it so that it becomes 2 times 3 in parentheses times x. And let's see, where else can I rewrite? All right, and 5, oops. I've got the 5x times 4 here. I can rewrite that as 5 times 4 in parentheses times x, which is going to give me 20x. So the first thing that I've done is I've rewritten the terms so that there's coefficients in front. Think of it as multiplication coming first. I'm taking care of the multiplication part of my expression. Next, I'm going to do the addition part, which is combining like terms. I'm going to look for things that I can put together. For example, 6x and 20x can be combined, and I can put those together, and that's going to give me 26x. And then the 4 and the 1, those constants, can be combined to get 5. So my new expression is 26x plus 5. How about this one? Number 15 on page 194. 2x plus the product of 5 and 6x plus 1. First, I'm going to take care of rewriting it so coefficients come in front. So the multiplication part has to come first. So 2x stays the same. The 5 times 6x is the stuff we're going to work on. 5 times 6x gives you 30x because you can rewrite it so that it becomes 5 times 6 in parentheses times x outside the parentheses. And then I'm going to bring everything down. Think of it as like a order of operations, right? You take care of the multiplication, do a little bit at a time, bring it all down. And next I'm going to combine my like terms. I can put 2x and 30x together, and that's going to give me 32x's. And the 1, just bringing it along for the ride. I can't do anything with it. I can't combine it because it doesn't have, you know, a variable with raised to the same power, just like the 32x. So it's separate. So here are your takeaways. Here we have the definitions for the commutative and associative properties of multiplication and some examples. And then I talk about how by changing the order and the grouping of your factors, you can rewrite expressions so the coefficients are in front of the variables. And you can see the example here. 5 times 3x times 2x, I can rewrite it so that the 5 and the 3 and the 2 are in parentheses, and the x can be in parentheses because I can rearrange the order. I can group them any way I want. And 5 times 3 is 15. 15 times 2 is 30. And then I can put the x times x together to get x to the second power. And I now have 30x to the second power. And then put it all together. If you have multiplication and addition in your expression, first rewrite multiplication so the coefficient is in front, so you're doing the multiplication stuff first, and then add your like terms. Addition comes second. And you can see the example here. I've rewritten 2 times 5x plus 3x plus 4x times 2x to become 10x plus 3x plus 8x to the second power, because 2 times 5x gives me 10x. And 4x times 2x is going to give me 8x to the second power, because 4 times 2 is 8, x times x is x to the second power. 3x, of course, just came along for the ride. And now I combine my like terms. I can only put 10x and 3x together. That's going to give me the 13x. Because 8x is to the second power, that's separate. I have to keep that different, separate from 13x. So 13x plus 8x to the second power. So you can take some time to record these takeaways, and make sure you record the examples. The examples are going to be really helpful to you when you go in later and try to remember how to do all of these things.